Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Here we are now to hear talk about strategic thinking for researchers, and my colleague Andy Gordon, who's the principal researcher in the Programming Principle and Tools group. He also heads that group, and I introduced him yesterday because he's also involved in the Edinburgh Initiative, being a visiting professor there, and really being our point of contact at University of Edinburgh. So Andy is here to share his sort of long experience on research and the kind of wisdoms that he derived in the course of the years. Thank you very much, Andy.
Thanks, Scarlett. Hello, everyone. I hope you're having a good time in Cambridge this week. I hope you like this quote. This is one of the quotes that got me into computer science. I read this when I read a book called Structure and Interpretation of Computer Programs. When I was a sort of final year undergraduate, and it got me totally stoked about research. So I like to put up, and this man here, Alan Perlis, is pretty cool. I mean, he was the first ever AM Turing Award winner back in '66, and he was one of the people who was on the Algol 60 committee, which is a hugely influential programming language. So he's a pretty cool guy, and I love the quote. So this talk is about strategic thinking for research success for researchers. And it's really about what you do beyond sort of writing single papers. So I think you were at Simon's talk yesterday, and he gives a lot of great tips on how to write a paper, how to come up with ideas for an individual paper, and so forth. And what this talk really is about, the sort of longer-term strategies you might have in the course of doing a PhD and in postdocs after that, and in your whole career. After that. So I'm sort of thinking at different levels of your career here. And I think it's worth thinking a little bit about this because, I mean, many of us who are sort of passionate about research and make it our careers pretty much make it our lives. I have to say it can be long hours, particularly at the beginning and midpoints in your career, some late nights and maybe a bit of weekend working from time to time. So if you're going to be putting that much effort into your research, I think it's worth thinking strategically about, how to get the best value from that. Now, this talk, it's kind of funny for me giving this talk, because normally I give technical talks, and you're always talking about an original contribution. I'd say there's no original contributions in this talk, really. It's a sort of potpourri of ideas. And also, I feel let off the leash a little bit here. I'm going to pontificate a bit about some ideas that have had an impact on me, and I think have been, I think pretty much everything I'm going to talk about, I've tried at one time or another with more or less success. And I want to try and pass them on. I wouldn't say there's one particular correct strategy, but I think there's some common points I'll bring out. And as I say, I mean, like most advice that people give, you find that there's few people who follow it all of the time. But I think some successful people do follow this sort of thing, some of the time at least. And what about me? So why do I feel qualified in doing this? Well, why not? You've got to put yourself forward. I've been around for a while, as Scarlett says. But actually, a few years ago, with a colleague, Tora, I had a huge amount of fun here because we organized a workshop for researchers at Microsoft about impact. And we called it Making a Difference by Research. And our goal was to figure out how to have impact. And we had this sense that the point of the afternoon was to make us stop and think how our work can change the world. Make us stop and think how our work can change the world. And that's really the point of this hour for everyone here. Let's move away from maybe the paper you're thinking about writing or your final year report or your, whatever, your dissertation. Think about the sort of bigger things that you might do with your career. So that was a huge amount of fun, organizing that. And so we did something the next year, which was this. This is the MSR Speed Dating Society. So what could that be about, do you think? Well, there were some misunderstandings. We invited one person. one of our visiting researchers said, Andy, I can't come. I'm a happily married man. So what we actually did was we thought that, well, this is our slogan, that we thought social links would lay foundations, this is a bit fancy, would lay foundations for eventual transfer of expertise and serendipitous collaborations between the lab, members of the lab. But really our point was to have a bit of fun, to have 90 minutes surprising each other. And you know, our lab now is like on separate floors, so sometimes people just don't meet very often. It was a little different then, but still people didn't meet that much. And this would be true of your universities, quite possibly. You know, there'd be parts of your department, of researchers there you don't often meet. So the point of this is to try and break down some of those barriers, because I personally have found in my own career that some of the work that I've done that's been sort of most influential has been where I took ideas from one area and applied them in another. And you just can't do that if you don't know about the other areas. So the idea here was to get people talking to one another. So what we actually did was we had 24 folk came and everyone gave a short pitch about something surprising about themselves, about their research or their life or something. And then we organized these speed dates where we paired people up for 5 minutes to talk about what they were currently working on or whatever came to mind technically. And it was good. We had a morning after survey and people were keen to come back. So I felt that was a good thing. Okay, so that was a speed dating society. But let me move on to the sort of real content. I think this is one of the most important things, is know what you're trying to do. So I've got a couple of quotes up there that actually at first sight seem a bit contradictory. So Bjarne Stroustrup, legendary inventor of C++, a great computer scientist. The most important single aspect of software development is to be clear about what you're trying to build. And then Wernher von Braun, who is a famous rocket scientist in Germany and the USA in the middle of the last century, very successful rocket scientist. He says, research is what I'm doing when I don't know what I'm doing. So how do we square that? Well, the point is that you should know what you're trying to do. In some ways, it wouldn't be research if it was dead easy to solve the problem. But you need to have some kind of conception of what you're trying to do. And then all the work you do, the prototypes, the cut-down versions that you try to solve before moving on to the big thing are sort of pushing towards that larger enterprise. So you know what you're trying to do. So here's a job interview question. What's the most important problem in your field? In fact, let me ask you that. Anyone want to call it out? I don't know what people are doing here, but what's the most important problem in the area that you're working in? Anyone? What was that? PLP. What's PLP? Oh, P was MP. Oh, perfect. Okay, good one. What else? Okay. Now these are the most important problems in the area that you're working in.
Yeah, one of the most important.
Okay.
Artificial general intelligence.
Okay. So then the follow-up question is, what are you working on? Well, I won't put you on the spot. So this is I've sat in a job interview where I've done this, and someone has said, "What's the most important problem in your area, Andy?" And I've said such and such, and then if they turned around and said, "What are you doing?" And I've said, "Well, actually, no, I'm not working on the most important thing." So I guess the point is, if you've got a conception about what the important problems are in your field, then maybe you can't stop at once to work on them, but you should move towards working on them. And then another point is serendipity. That chance connections between things. This definitely happens, but we shouldn't rely on it. This is Louis Pasteur, and his slogan was "Chance favors the prepared mind." So you should, his point was that various serendipities happened to him, but it was because he was ready for them. He knew the rough areas, and then he could make connections. So you shouldn't just rely on chance. You should have a clear idea of what it is you're trying to do. Said otherwise, you've got to work on important problems. So this is Richard Hamming, and he has a great essay called "You and Your Research" that you could go look up on the web. It's quite a long essay he gave back in the 80s, I think, to members of Bell Labs. So he's one of the early guys in Bell Labs. He's very famous for his work on foundations of information theory, and he's a great essay about what it's like to work in corporate labs and part of what he's talking about is that you really need to work on important problems. And he actually spent Friday afternoons, when he wasn't doing other things, he would set them aside to ask what the big questions in his area were. And then over time, he would sort of change his direction towards what he discovered on the Friday afternoons were to be the big questions that he was, that occupied the field. So don't work on unimportant problems. And don't do a peanut butter strategy, which is where you kind of spread yourself thinly over lots of different problems and don't really concentrate on anything. So you need to be biased. I guess that's the harder bit of these two slides would be trying to figure out what's important and go towards them rather than doing lots of little things. Okay, let me move on a bit. Where do ideas come from? This guy, Steve Johnson, has a great book on the topic and a great TED Talk on the topic. And there's a sort of, through his analysis of where ideas have come from, where sort of famous inventions of history have come from, I think we can take some comfort. What do I mean? Well, this is the, he sort of categorized inventions in various ways. So he says a lot of them come down to collective effort. So this is double entry bookkeeping, which was codified in, I think in Florence in the 15th century. But in fact, it had arisen, the idea of counting out your outgoings and your ingoings and making them add up, that idea had arisen in lots of places, but hadn't been properly written down and codified. But it was sort of in the air, and had sort of been developed collectively, and eventually was codified. Another kind of invention is combinatorial. So this is Gutenberg with the printing press, and he took four things. He took ink, paper, the press, and movable type, and put them together. I mean, all of these things existed in precursor inventions, but he was the one who brought them together to make the printing press, which was which has been hugely important. And then a third kind of invention is this. This is a Willis Carrier, and in 1905 in New Jersey, he invented the air conditioning machine. He was working for a heating company, actually, and some of the customers came to him and said, look, it's really hot and it's really humid. We can't work. We don't need heating. We sort of need cooling. But it's not just cooling. We need to take the moisture out of the air. And he figured out how to do that. And he had some sort of this eureka moment where it was misty, and he was just looking out over the river, and he was thinking, maybe I could create an artificial mist. And then, that kind of hunch, that question, led him to figure out how to do that, using this contraption. So what's comforting about this? Well, when I was a PhD student, I was thinking, gosh, how am I ever going to come up with big ideas like Willis, this eureka moment where from nowhere, someone seems to have come up with this amazing idea. But the comforting thing is that in Johnson's analysis of inventions going back, this hardly ever comes up. It's like a small fraction of major inventions are like this, where one single individual sort of conjures something up from sort of nothing. Instead, sort of collective effort, and in particular combinatorial ideas, are much more common. Most inventions, in fact, are not that original. They're rather like the printing press. They're technologies that already existed, and nobody had thought of how to combine them in a particular way, and then the inventor figured that out and then kind of made a big impact. So I find that quite comforting, because I feel reasonably good at combining ideas, but completely coming up with ideas from scratch can be a tall order. So I recommend his book. It's called Where Good Ideas Come From, and it's a TED Talk. And he comes in the book, he describes a lot of different strategies people have for what he calls exploring the adjacent possible, which is the sort of set of ideas that are sort of about to be discovered, or the set of inventions that are about to be discovered. And I'll talk about a few of them. One of them is what he calls liquid networks. And this is a way to facilitate this kind of combinatorial, this combination of ideas, like in the printing press. And so liquid networks are things like coffee houses, centuries ago, and even today, just meeting people, or cities. Great advice to a scientist is to live in a city. So in a sense, scientists living in Cambridge are at a disadvantage. They'd be better off living in London, though don't tell our boss that. Simply because if you live in London, you're more likely to go to parties with a broader range of people and just come into contact with more sort of ideas and be able to make kind of funky connections. And of course, the internet these days is a kind of sort of artificial city that allows that sort of thing to happen. Then the slow hunch. So Darwin, of course, discovered the theory of evolution. And if you read his memoirs, he actually believes that on a particular date, September 28, 1838, he believes that's when he came up with the theory of evolution. But what's interesting is that one of his biographers went back and read his diaries for a period, like for about a year before, well, and sometime after. And it turns out that he essentially had got those ideas in some form for at least a year before he sort of felt he had this eureka moment. And even after the supposed eureka moment that he claimed afterwards was when he kind of got it, you can read from his diaries that he hasn't really completely kind of got it, if you see what I mean. So the point is that very often the way ideas come up, and I've had this experience myself, is that you kind of have this hunch for quite a long time that something is possible, but you don't quite know how to do it. And eventually sort of things fall into place. But again, it's quite rare for it to be a single eureka moment. And indeed, often people who think they have had eureka moments, in fact, didn't, like in the case of Darwin. Serendipity. So here's a few serendipitous things. So LSD was actually invented for medicinal purposes before they figured out that it had a sort of hallucinogenic purpose. Teflon, famously, man for the moon, was a nice byproduct. And Viagra was originally invented for hypertension by Pfizer, and then they figured out that it had, other applications, as it were. So serendipity definitely exists. And then finally, error. The role of error is, I mean, people hate to make mistakes, but in fact, you should make mistakes because actually that's often you learn from it. So this is Lee DeForest, who was a colorful sort of inventor and businessman at the beginning of the 20th century. And he invented sort of electronics. This was his first thing, the Audion, which was the sort of prelude to the sort of triode and the vacuum tube and so forth. And he managed to make an amplifier out of it so he could start to do electronic type things. And he thought that it worked there's a gas, I mean, it was a rarefied gas, but it wasn't like the technology for creating vacuums was lesser than it is today. So there was still quite a lot of sort of gas in this thing. So he thought that the amplification worked because of ions rather than sort of, I guess, or actually I'm not a physicist, but sort of electrons flying through the vacuum. So he's completely wrong about how it worked, but he still kind of worked on it and managed to get it to work, even though he didn't understand it, and then made a great business out of it and went on to be very rich and have lots of colorful experiences, like people defrauded him and he defrauded them, and he had 4 wives. It was all a bit of a mess, but I guess he had a good time. So I hardly recommend this book. I don't have time to go into all the details, but it's a good read for strategies about coming up with research ideas. Okay, let me switch tack a bit toward life in research labs. So this is Don Syme, and he invented the programming language called F#. I don't know if Don has given a lecture in the school.
Kenji's talked about F# in the Power Station this morning, and Andrew mentioned it yesterday.
Okay, but you've not heard from Don himself.
No.
So this lecture really is about all stages in your career. And one of the great things about coming to work in a corporate lab is that it's possible to take time out from writing research papers to actually really focus on doing something substantial within the company. And that's something that Don did, and he's in our group PPT, and he's one of our sort of poster children, so don't quote me on that to him, for some great tech transfer successes. And so he, let me just go down a bit. He joined the company in the late 90s, and one of the things he did was .NET generics, which had added sort of polymorphic types, generic types to .NET, both to the actual common language runtime and also the C# programming language. So the original C# didn't have generics, and he was the one who actually added them. And he had to go all in, as he puts it, in this period where he wasn't doing anything else than sort of hacking C++ code to get the runtime to support generics and to get that to work. And then he built this programming language, partly as a way to show off what you could do with a runtime that had generics. Actually from the start in a sense, but really all in on it from 2007 onwards. And these are notes from his slides actually on it. And let me just go down. Okay, so he's here really speaking to us research to encourage his colleagues to get involved in this sort of thing. Saying, in order to, so it's quite a challenge actually for us as researchers here to reach out to people in Redmond who are building products, because they tend to be on fairly short timelines and there's very specific things they want to do. Whereas here we've got a great deal of freedom to research the things we want to do over a long period, and we're in a completely different sort of management chain. So for them to trust us is kind of a big deal, because we don't, it's not that we report to people over there, so they can't sort of give us a hard time if we're not doing what we said we'd done. So here's his advice: that you need to go in, be fully dedicated, get respect, find actual tangible problems that they care about. In this case, it was doing .NET generics, and figure out how you can take research ideas and apply them to enterprises that, say, the company, and I'm talking about Microsoft context here, cares about. Another point was, often the company has a particular shared vision that's promulgated from the top. Like Bill Gates was all behind .NET. At the time, it was strategically super important for Microsoft to have an alternative to the Java sort of ecosystem. So it was important to have a managed code runtime for web servers in particular, and languages like C# and F#. So he's got a lot of stories about this. I mean, sometimes it's difficult, for sure, because of the different values, but it's an opportunity to really make an impact in the company. And he said there's lots of upside if you can get something into a product, but in order for them to trust you, you've got to be sure that you're really fully committed to the enterprise. Okay, so then, sort of related to that, who's this? This is George Heilmeyer, and he's quite a character. So he was at the DARPA, the American funding body, in the 70s, and he was a great engineer by that time. So he was one of the pioneers of the liquid crystal display. And I always pause. Think about that, the liquid crystal display. There must be hundreds of LCDs in this room, and they're all around us. Talk about impact. It's an amazing bit of technology to have produced. But when he was at DARPA, he had this checklist for projects that were going to be funded. And I've recently had dealings with DARPA, and I'm told they still use this checklist. They still talk about the Heilmeyer Catechism. So this is, and I think I put these up because I think at any stage in your career, in your PhD and then later on, it's really useful when you formulate projects, even for your own purposes, but also, say, for applying for funding, for grant proposals, for example, to answer these questions. And these are maybe a little, key what are you trying to do? Going back to my key point, who cares about it? There's no point in doing something if nobody actually is interested. If it were to work as you hope, what difference would it make? What impact would it have? And then, if you're trying to get some distance, but what are the intermediate points? So that's a bit abstract. So let me imagine I'm Don Syme, and I was, I'm filling in the Heilmeyer Catechism for my .NET generics and F# projects. Then what would I say? So the first thing is, what are you trying to do? So what Don was trying to do was allow benefits of type functional programming to on the .NET platform. There is a little bit of jargon there, I admit, but I think in the context, say, of making a pitch to people in Microsoft, it's fairly, jargon-free. How is it done today, and what are the limits? Well, when he started out, there was C# 1.0, and it had no generics, so it meant that you couldn't get the benefits of code reuse that you would get with generics and with functional programming. So there were no sort of there were no functions as such, and there was no type inference. And what would be new in the approach, and why do you think it'd be successful? Well, the new thing, I guess this is specifically about F#, the new thing would be the simple syntax compared to C#. And why do you think it'd be successful? Well, he had a good start, because the team was planning that the common language runtime be a common language runtime in the sense that it could support multiple languages. So they kind of had said they wanted to support other languages. And there were in fact enough instructions and flexibility in the type system that compiling something like F# was actually feasible. Who cares? Well, the original customers of C# 1.0 were probably folks making websites, and in that kind of setting, F#'s nice, but it's not maybe a killer. But on the other hand, there was a potential market in the financial industry of people in sort of finance, sort of the quants in finance, who want to do automatic trading and so forth. And these people have turned out to be really super interested in functional programming and in F#. So and ultimately, when he managed to turn F# into an actual product, it was making this kind of argument that caused them to decide to go with it, rather than because it was a better way of making websites. And if you're successful, what difference would it make? Well, here you're thinking in a sort of business setting, what Microsoft, like other software companies, tries to do is to lock in customers into their technology. So the hope here is it would better attract and lock in, the people the institutions that have these wizards to things like .NET. And what are the risks and payoffs? Well, risks would be that the product group wouldn't support them very much, and in fact, he did experience that problem, but he stuck with it. It was the sort of thing that a single person could do. And the payoff, well, it's a way of transferring our ideas. How much will it cost? Well, Don, as I've said, would have to go all in on making it happen. But in fact, it's just about the sort of thing that a single person could do if you're a great coder, which he was single-handed for a while, and then we got other people to help him. And how long will it take? Well, the basic thing was less than a year, and then in terms of midterm, and it must have taken like maybe 8-9 years before it eventually became a product. So it was quite a long gestation period. And there were a series of sort of midterm tests. There was a basic system, could it compile itself? Then there was a free download, and he got customers using it. So I think these are a great set of questions for almost any enterprise. And so if you're writing a grant proposal, I heartily recommend you to think about these questions and use them to sort of argue for what you're going to do. Okay, seek criticism. So I think this definitely applies as a PhD student. You should, you've got your ideas towards you know what you're trying to do. You have got some ideas about how you're going to get there, but you're still very inexperienced. You don't know the whole literature. You don't know sort of what works and what doesn't work. So you really should put yourself out there and get feedback. So write proposals. I mean, you will be asked to do this, of course, during the course of your PhD. Write proposals, and they're great. People always complain about them, but actually it's really good to write down what it is you're trying to do, what your sort of path to impact could be, and you get feedback from your sort of formal committee. But I'd heartily recommend you don't just do that. Go beyond what the university asks you to do and get people together, force them to listen to your talk about what it is you're trying to do, and get their feedback. And if they don't give you any feedback, that might be because they really are critical of it. And sometimes people are rather loath to be critical of others in public, though it doesn't apply to everyone. But if people are very silent, I mean, take them aside at some point and force them to give you feedback and listen to them. I mean, this is John Wheeler, who is a physicist who gave black holes their name. And about research, he's saying the fundamental problem is to make the mistakes as fast as possible. So the idea is get the mistakes out there and get feedback so that you can rectify them and move on. Reviews and planning of projects. It's easy to fool yourself, hard to fool peers. It's the same sort of thing. Get your ideas out there. Maybe if you review what you've done over the last year, give a talk about it to your group, get the feedback, and don't worry about the failures. So I always love this picture. These are the two men who gave me my big break in Microsoft. This is Roger Needham, who was the first leader of this lab, and he was professor at Cambridge University when I was there. And of course, this is Bill Gates. And Bill went to Roger when he hired him to set up this lab. And he said, hire the best people you can. He said 3 things. Hire the best people you can. Let them do whatever they want. And thirdly, he said that if all your researchers' projects have succeeded, then you have failed. And when it always seems strange that Bill wanted things to go wrong. And the idea is that if people are not making, if people basically propose that they're going to do something over the next year, and then at the time of the review, it's all just simply happened, no problem, it means they're not pushing themselves hard enough. It's like they've said at the start of the year, right, over the next year, we're going to go to Sainsbury's. And then at the end of the year, they report back, yep, we successfully made it to Sainsbury's, right? So in a sense, it's been successful, but kind of boring. What you really want is your people to come in and say, Roger, this year we're going to go to the moon. And at the end of the year, they say, well, we didn't quite make it to the moon, but we did make it to the space station. Or we discovered Teflon, even though we didn't make it to the moon. let me see, in terms of numbers, I think, I was thinking maybe we've had 100 projects at MSR Cambridge, or maybe 200, I don't know, I've not counted this out. And I'd say, say 100, 200 projects that are sufficiently big that a few people are working on them and you know, they'd be presented to management. And most of them have ended up successfully producing papers, which is great. I mean, it's not quite like going to Sainsbury's, but it's a good thing to produce papers. But we've had, you know, I don't know, 2 or 3 what I would call successful moonshots. And so I say F# is one of them. Say Connect is another really famous one, where, you know, it really just has had a huge impact. And that's why Gates set up the lab. And that's why Gates gave this advice to Roger, that he didn't want all little projects to succeed, because he wanted people to feel empowered to go for big things and not be fearful of failure. Because that's the whole point of a corporate lab like this. I mean, he's already got great people in development who are just awesome at getting things done on very tight timetables. He wants a corporate lab full of researchers to dream big and occasionally to have a really big impact. And I'd say that's been successful. And that generally, I think that should apply to researchers in all situations, and in universities as well as corporate labs. The whole point, the reason government has universities doing research is that they want really big ideas to come out that will produce new businesses and produce really great knowledge, you know, new insights to change the world, not just sort of, you know, succeed at getting to Sainsbury's. Another thing, don't be seduced by proxies. So as time goes on in your career, you'll find you're invited onto program committees, and people start to cite your papers, and you're asked to give invited talks and so forth, and you start to release software. Now, it may be that's why you came into research, and in fact, downloads could well be a reason you want to produce some software that you want to get, you know, to get it out there. But generally, it's other things. You came here to change the world, not necessarily to sit on a zillion program committees every year. So people get brownie points, as it were, from university administrators and research assessment exercises for these kind of things. But I would say, you know, give lip service to that. I mean, to some extent, it's a necessary evil to count those sort of things. But don't confuse these kinds of proxies for what it is you're really trying to achieve. Work in collaboration. So, okay, some pontification about collaboration. Collaboration is great. Let me see. Individual versus group work. When you do your PhD, often it's individual, you and your supervisor. But as you get more senior, you often have a chance to work with people. So this is Edsger Dijkstra, a great sort of formal methods guy, great computer scientist. And his slogan was, only do what only you can do. So figure out what your unique contribution is, and you know, and do it. But if you're on a project where essentially anybody else could have done it, you're probably wasting your talents, and maybe you shouldn't be in that collaboration. Your team needs pigs, not chickens. So people are always puzzled by this. What does this kind of mean, pigs versus chickens? Well, it's about the degree of commitment people have to a project. Because you often find in the project, you know, there's a few people that are really driving it and are fully committed, and then there's a few people who are kind of sort of on the fringes who are helping out a bit. So why pigs and chickens? Well, it's the analogy is with your breakfast plate, with your bacon and eggs. So you can say that the pig is fully committed, but the chicken, you know, is only involved. So remember, you need pigs. There's some you need chickens too, but you definitely need some pigs. Okay, so more in collaboration across disciplines. So this is Walter Scott, a great Scottish novelist from the 19th century. And one of his plays, a great line I like, one half the world thinks the other daft, which I think is just forever true. You know, we always divide up into different groups and think the other side is daft. And this definitely happens across disciplines in universities and within subjects in corporate labs in universities. So that's a thing to be wary of. So it means that the paper you might write for, I don't know, my favorite, well, say Popl, is not the kind of paper you would, which is Principles of Programming Languages, not the kind of paper that would make it into, say, an operating systems conference, even if it was really about programming languages applied to operating systems. Communities have different values, and it's necessary to respect that when you write papers. Subjects are conveniences for administrators. I heartily agree with this. You know, it's just science. You know, all these different enterprises we have. You know, they're given different names. Like machine learning is in a funny old situation like that, in that machine learning can be called statistics or machine learning or statistical chemistry or ... There's lots of different names for it, and it's the same kind of thing, but it's done in different university departments. So the administrators are sort of cocked up, or at least are divided up this subject, unfortunately. So I would highly recommend doing interdisciplinary work, because in fact it can be, like I said at the start, it can be very impactful if you take ideas from one area to another, because often people get a bit siloed, and communities get siloed, over a period of years. But wait till you get your PhD, because it can be a bit of a risk to do this during your PhD. You need to kind of master one discipline first. And if you do interdisciplinary work, only one specialist per discipline, or you'll find that the two programming language experts will argue about whether you should use a gamma or an E for an environment, for example, or whether it should be a big step semantics or a small step semantics. They'll argue about this sort of stuff rather than collaborating. So that's my view on collaboration. Okay, so now I've got some slides, and these two are mainly aimed at theoreticians, and then I've got one slide more aimed at practitioners. So, theoreticians. So this is one of my heroes, Robin Milner. He was a professor of mine when I was an undergrad up in Edinburgh, and in '85 he established the Laboratory for Foundations of Computer Science. And what I always loved about his emphasis, which is a little unusual in theoreticians, was that he really wanted an interplay between theory and practice. So he says, his thesis is that the design of computing systems can only properly succeed if it's well grounded in theory, and that the important concepts in the theory can only emerge through protracted exposure to application. And I think that actually that was something he did follow in his career. So test theory and practice. Here's another quote of his that he argues that physical scientists use carefully controlled experiments, and the same should be true of computer scientists. That theory should be tested in practice. And he always took theories, but always tried to do practical things with them. So he had a series of influential systems. So back in the 70s, he invented something called LCF, which was a theory-improving system that needed a programming language that was typed, because he wanted to have a theory-improving system that would let him formulate unproved formulas as goals that were to be proved, and then have a type, an abstract type of proved theorems. And the underlying representation of that was simply the formula, but it could only be put into that type if you went through some of the inference rules of logic. And then he built up this grand sort of apparatus of functional programming to make it easy to automate part of the tasks of doing that. And in the course of figuring all that out and of introducing these abstract types, he invented this programming language ML. And ML has gone on to be hugely influential, so it's led to languages like OCaml, F# that I've spoken about, and also Haskell. And he also similarly worked on concurrency and started with concurrent programming with a formalism, a theory of concurrency, and then it's been applied in various ways and led to some successful programming languages. So if you're a theoretician, it's great to explore mathematical ideas. But if you want to sort of have an impact in computer science, I think it's really important to figure out how those ideas would apply to practical things. And I think Robert Milner's work is a great example of that. On the other hand, moving more practically, I think this is Eric Ries, and he's a book called The Lean Startup that's quite popular in the sort of the startup community over the last couple of years. And I think it's not too much of a stretch to take the ideas that he applies or that he expounds for doing startups to apply them to your research, particularly if it's quite practical. This doesn't apply to everything. This is probably not the way you would do theory, but I think if you're trying to build something that people actually would use and want, then these ideas are useful. So his definition of a startup is one that's an organization that's intended to create new products and services under conditions of extreme uncertainty. And I think that applies to research, if you think about it. That's what we're trying to do. We don't really know what's going to work, although we've got a fairly good idea of what we're trying to do. And he argues that learning what your customers want and what will work is the thing that a startup is trying to do. And he argues it's extremely easy to kid yourself about what customers want. In particular, what you often do is think about yourself as the customer and invent something that works for you rather than what your actual customers want. So he advocates what he calls validated learning. And let me give an example of that. And in particular, let me just go to this. He has this idea of a minimal viable product. So he argues that you shouldn't wait until your software is completely ready and bug-free before putting it in the hands of customers, because it's sort of too late. You spent too long producing that, and maybe most likely you produced the wrong thing. So you want to, as soon as possible, as soon as practical, put something in front of customers that can get feedback from them, so to help you guide what is actually worth investing in. And he wants a version that can allows you to iterate, build, measure, learn, and then build again, and so forth. And so he's got a few examples. So one of them is simply a video. So Dropbox, that's become a hugely successful startup, they didn't quite know exactly what sort of features to put into their product to start off with. So they just made a video. They sort of cooked up a video of the sort of experience they expected that Dropbox could give, and put that on their website. And suddenly had a lot of people expressing interest in getting this, and they got a lot of feedback from that. Another example is a company that was called Aardvark, I think, and they wanted to create a website that would let people that would shop locally would fulfill menus by shopping locally. And the idea was that the website would suggest an actual menu to somebody, and then it would figure out which local suppliers would provide the ingredients and get them to the person. But they weren't quite sure whether this would work, and it was going to take months to actually build the software. So what the CEO did was he put out some adverts for people who would like the service. So he didn't have anything that worked, right? He put adverts out. Eventually he found one person who was prepared to pay $10 a week for this service. So what he did was he just went down, found this person, and sat down beside her and said, "What would you like for your supper this Saturday?" And had a conversation with her and figured out what sort of menus that she would like, and then would go ahead and figure out how to source them from local supermarkets. So no software, no investment, nothing like that. It wasn't a perfect product because there wasn't a product. It was just him. He sat down with somebody, and it was key that the person was paying him. So this is the validated learning. It's like someone who actually is interested in what you're trying to produce. You get direct feedback from them. And so they became a success, and it took them some time before they got the website going, but in the end, it worked out. So that's the, and there's another, well, anyway, let me move on. So that's the kind of idea. So if you're trying to build something that's practical like that, consider putting a really kind of minimal sort of product in front of someone, and possibly without a product at all. Or the other example was a website that was to answer questions, using AI, and it was a sort of Wizard of Oz product. So there was a website, and you could indeed type questions in, but behind the scenes, they had people who were searching the web to answer the question. So it came back with an answer a few minutes later because a human was sort of working on it. So that, I don't know if that really worked out, but at least they got some ideas about the kind of questions you could conceivably, or they learned what questions people wanted to ask by doing that. So think out of the box about getting feedback on what's actually useful. Oh, there's my prompt. Okay, work with the system. So sometimes people don't. How am I doing for time? Okay, I think I've got enough time, quarter of an hour. Okay, good. So, work with the system. There's huge ranges of resources at your disposal, and I want to just tell you about a few possibilities. So this guy is Clay Shirky, and he has a book called Cognitive Surplus. He's a great sort of thinker about the internet. And his thesis there is that in the sort of developed world of sort of white-collar workers, there's just a huge number of people who've got what he calls cognitive surplus, that they've got hours free in the evening which they might contribute to some enterprise, like people who do open source coding in the evenings, for example. And these are people that we can exploit, or at least, well, maybe not exploit, but they're there, So in fact, Don Syme did that. So I mean, his project has well, certainly the last few years has, in fact, forever really, has really exploited the fact that people, in their hobby time are quite prepared to play with F# and contribute code to it and so forth. I mean, there are lots of stories about successful open source projects, but it also applies to science. So there's great, there's a lot of sort of citizen science going on that you might consider exploiting. So So in astronomy, there's something called Galaxy Zoo, which is a website that shows up images, really distant images of really distant galaxies. And then humans are sort of trained to sort of classify them in different ways. And a lot of data is sort of being sourced that way. And they made some great discoveries and published papers. So maybe you can come up with an idea to do that sort of thing, to sort of crowdsource input to help with your project. With the system, if you fight the system, be very careful. So going back to Hamming, he says, which do you want to be, the person who changes the system or the person who does first-class science? So some examples, like I have this part-time position in Edinburgh, and I know people there. We moved into a new building, and all these nice whiteboards were installed, but some guys really wanted old-fashioned blackboards with real chalk, and made a huge fuss about this, and fought the system, and eventually prevailed, but really spent days and hours complaining to lots of administrators about it, and it was kind of pointless. This guy told me afterwards that, he'd sort of done it at the time, he'd only recently joined. He wanted to make his mark, but he realized in the end he'd be much better off teaching students or doing research than sort of fighting for blackboards and so forth. Another example is, there's a story here, there's a person who joined MSR some time ago and decided that he wanted to have a dot in his name, in his email address. So let's say it was f.blogs, just to maintain some anonymity. But Richard made a big mistake there. So he's got a dot in his name. So no one else in all of Microsoft has a dot in their email address. So it means that none of our systems that are, none of our sort of personnel, HR, etc. systems that record data about people have been tested on user IDs that have dots. And so sure enough, recently, because there was a dot in his ID, some crucial HR system, failed, and he didn't get a bonus. So, or something like that. Maybe I exaggerate a little bit, but it was a mess, So he's wasted a lot of time because he insisted at the start of having the dot. So that's what I mean. It's a good idea just to go with the system. And finally, invite yourself places. So I think you can recognize this handsome young man here. So this is this is in 1992, and I'd finally ceased to be a student. And I'd got my PhD, and I got a paper into a conference in Boston, and I was a student here in Cambridge. And the university said, sure, Andy, you should go, and we'll pay for the airfare. So I said, fantastic. And I thought, it's kind of a shame to go to Boston for like 4 days or something, which is all they would pay for. And someone said, well, Andy, why don't you just invite yourself to a few universities? And I said, you must be joking. Why would they take me? And they said, well, they've got lots of money, more money than we have here. I went, yeah, okay. And I said, they'll even fly you from place to place. So I thought, well, why not? So I started emailing. And sure enough, it was great. They all said yes. So I had this amazing tour. I flew into Boston, and then I went down to Yale, New Haven, and then I went to DC, and that there is the Watergate building. So this is in DC, in the middle of what I came to call the Andy Gordon North American lecture tour. You've got to put yourself forward, no one else will. And so I get to DC, then on to Chicago, went then up to Calgary, where I had altitude sickness and was chased by a bear. It was very dramatic. And then I got a bus through to Vancouver, and then down to Berkeley, and then eventually back to New Jersey, and then home. And I put yourself forward. Just ask yourself. The larger point is, so do that. That's a specific suggestion. If you get money to go to the States or Asia or somewhere, don't just go to the one university, but ask around. People would love to have you visit and give talks. Really, it's great. And they'll probably pay for your accommodation. And in fact, in some of the universities, they paid me a fee. I was astonished. I should have asked for more, actually. I got like $100 checks. It was great, really great. So really do that. It works. And I speak to a lot of graduate students, and I tell them this, and no one has ever heard of this, and nobody seems to be doing it. But you should do it, because they won't say no. Okay, go with that. Now, right, maintain balance. Okay, now I'm going to get a little spiritual. And I think this is really important. That these are great jobs. It's a lot of fun, but it's also demanding and stressful and anxious making. And it's partly because no one will tell you what to do, which is a great thing. I would hate to be in a job where people told me what to do. But at the same time, it means if things don't go work out for a while, it can be kind of stressful because it was your ideas. So I got a few strategies. Get some exercise. This is Turing, of course, who was a marathon runner. And I'm sure that was I'm sure that was super satisfying. You get some exercise. Here's Alan Perlis that I mentioned at the start. Remember, it's supposed to be fun. If it's not been fun for a while, maybe you ought to think about why that is. And this is Kathleen Fisher, who is a colleague of mine, and she has a great talk, actually, at this URL here. I recommend you check this out. And it's called, in fact, it's called Maintain Balance, I think. And she says, she's relatively philosophical about how to pursue a career as a professional in computer science. Philosophical in the sense of like asking you to divide out your principles, work, family, community, and so forth. And she's got a lot of tips. I don't have time to go into them, but I heartily recommend this PDF. And then there's this. This always gets me, I'm afraid. The 5 regrets of the dying. If you find yourself working too hard, I try and think, well, what would it be like, would I want to regret this when I'm dying? And unfortunately, people do. This woman, Bronnie Ware, worked in a hospice and with a lot of men who are dying. And these are the top 5 regrets they had. So, yes, take it easy. Take it easy. 12 resolutions to grad students. This guy, Matt Might, possibly works too hard. He's an amazing website, mattmight.net. He's a programming language guy, and he's got some great resolutions for grad students. So I suggest you follow these. Pick one a month. So in January, map out the year. Plan when the conferences are, when you're going to be submitting and so forth. Take time in February to think about your productivity in terms of your workspace. Maybe move the chair around or get a nicer sofa in the office or whatever. Embrace the uncomfortable. So if you're a theorist, write some Perl script. If you're a practitioner, I don't know, prove a theorem. Upgrade your tools in April. Maybe, get the latest packages for LaTeX or Emacs or something. In May, get out of the lab, go running, stay healthy. In June, you update your CV so you're ready to apply for a job. In July, network. You're at conferences probably. If you're at a conference, you just walk up to the famous guy and say, "Hello, Andy. It's great to meet you. I love the talk that you gave." Just network. Put yourself forward. I say you should put yourself forward because no one else will. Say thanks. I've actually not done this, but I should do this. If there's a paper you loved, just drop the guy an email or the woman an email saying, "I love that paper you wrote," it spreads some goodness, spreads some love. You'll be glad on your deathbed that you did that sort of thing.
Simon said the same. Spread some love.
Okay, spread some love. He went to my talk, so we're a version of this. Okay, practice some writing. Even it's writing a diary every day. If you're much happier coding than writing, which sometimes applies to me, do some writing. Maybe not in the pressure of like it's the paper for the deadline, but write a diary. Check with your committee, the people who advise you. In November and in December, think about the job market. And in fact, we have internships, so it's a good time to think about internships here because our deadline is the end of January. I think for internships or thereabouts. It's a good time to email someone here who you'd like to do an internship with. Don't let the system, don't imagine that the system will automatically figure out that because you came to the summer school or because we're sponsoring you that we will pull you in to do an internship. That might happen, but the best thing is to push yourself forward and ask. Okay. Now, your homework. You didn't know there was homework, did you? And this year, I would like you to do it. Last year, I don't think this was done. So there's 2 aspects of the homework. So the first one is the time management thing. An exercise for you to set some boundaries to manage email time better. So in fact, I think that's Chris Bishop at the back. He gave me this tip about delete, delegate, do, or defer when an email comes in. Process it really quickly. Ideally just delete it. Find someone else who will do it for you. Do it if it's less than 2 minutes, and otherwise defer it to some time where you plan to do it. Definitely switch off these notifications that come in that an email has arrived. That's just distracting. You completely lose your creative flow. And no email at weekends. That's maybe a bit tough. Okay, no sending email at weekends. And if you're a senior person, definitely no sending email at weekends. I think heads of department are very bad at that. We need some time off. We need to maintain balance. So that's setting a boundary. And now, the second part of the homework, organize a speed dating society. So I told you about this at the start. And like I said, it was, organizing it was so much fun, it didn't feel like work. So it's dead easy to do. And you might say to me, Andy, oh, I'm just a graduate student. Nobody would pay attention to me. You'd be surprised. They would pay attention to you. I mean, every institution feels this way, that there's, above a certain size, they all become a bit siloed. So go ahead, go back to university, either yourself or with someone else, organize a speed dating society, maybe tell your head of department or your advisor, and they'll say, go for it, I'm sure, I guarantee it. And they'll teach you how to plan and lead a meeting, and you'll be taking a professional initiative that you could put on your CV. And so this is you crossing a boundary yourself. You're crossing the boundary to being a researcher, someone who's an active person in their own right in the community. And if you do this, I would like you to email me and say, Andy, I did this, and like you said, it was a huge amount of fun. So please, hands up, who will do this? Okay. Okay, brilliant. I would like you to email me. Fantastic. Okay, that's what I've told you. Thanks for your attention.
Thank you very much, Andy. Time for a few questions. Yeah.
What advice have you given in this talk that you know some colleagues who vehemently disagree with?
Oh, disagree with? Oh, I don't know. Email at weekends. That seems to happen. I gave some version of this. I said, seek advice or have it imposed on you. And in fact, someone pointed out to me that often it's not imposed on you. If you give a talk and nobody likes it, what typically will happen is just a deathly silence in the room, and nobody will actually complain. Which is why I said, if there's a silence, you should do something about it. Impose it on yourself rather than expecting people to complain.
Other questions?
Yeah. This one here.
Your Heilmer catechism
Yeah.
brings up who cares, and that's fine for the DARPA prospects where they have to come out with a product at the end. But in research, you don't necessarily have the foresight to say well, no one cares right now, but it might have an impact in the future. So how do you address that from a research perspective? I'm speaking from the perspective of
but there must be some reason you're doing it. There must be someone who cares. And if it's just your advisor, you should ask your advisor, why do they care? And they will have an answer. And you should evaluate what it is.
What if it's just pushing to the next level of that branch of research?
Well, that would be, okay, the people who care would be other people in the community. Yeah, so at different levels, we've got customers at different levels. So often, very theoretical research, the immediate customers that you're trying to impact are other people in your community, rather than, say, the person in the street. Yeah.
Okay, another question here.
Oh.
Could you share some of the activities that you organized at the Speed Dating Society? Were there talks? Were there paper discussions, or was it something more scientifically informal?
No, it was very simple. We had, I think, 24 people or something, and everybody gave a half-minute or 1 minute sort of surprise on a slide, we called it. They gave a short presentation about something that they cared about or that was surprising about them, and then we paired people up, and we had 5 or 8 speed dates where people just paired together for 5 minutes for a conversation. So it was really very simple. And in the 5 minutes, you were supposed to kind of alternate. So one person would speak for half time, and then the other person.